So here in example 3, we want to demonstrate use of the empirical rule. So here's our bell-shaped curve. It is centered at the mean, which is a z-score of 0. So x values here, z values here. We added 1, 2, 3 standard deviations above and 1, 2, 3 standard deviations below. And then 68% of the data is within 1 standard deviation below to 1 above. So that means 34% in here and 34% in here. And then 95% is from 2 standard deviations below, z negative 2, to 2 standard deviations above, z positive 2. So that is this area here. So that's 95% of the data. So if you take that 95 and you subtract off the 68, that'll leave you 27. Half of 27 is 13.5. So 13.5 in each piece there. That's how we got those. And then 99.7% of the data from 3 standard deviations below to 3 above, which is almost the whole bell-shaped curve. There's only 0.3% out here and 0.3% out there. So that means that if you take the 99.7 and subtract the 95, then you get 4.7%. Half of 4.7, that's 2.35, which is that little area there. And then the same on the other side, 2.35 here. And then the 2.5% here is if you start at 2 standard deviations below and include everything. So the 2.35% is just in between here. But if you include that little bitty sliver there, then you get actually 2.5%. And same thing on the other side. Above 2 standard deviations is 2.5%. So you think 100% subtract off your 95%, which is in here, leaves 5%. Half of 5 is 2.5 on the top side and the other 2.5 on the bottom side. So here's how we use this. We have a standardized test, GRE, and the mean score on that GRE is 500. So that's going to be in the middle here, so 500. And then your standard deviation is 120. So that means to get to 1 standard deviation above, you add 120. So 500 plus 120, 620, plus another 120, 740, plus another 120, 860. So those are the cutoffs for 1, 2, 3 standard deviations above. And then subtract 120 3 times to get standard deviations below. So 500 minus 120 is 380. Minus 120 is 260. And then minus 120 is 140. So we want to know what is the proportion of students who scored between 380 and 740. So 380 to 740. So that is that corresponds to this area in here, which is 34 plus 34 plus 13.5. So you just add up the percentages here. So this will be 34 plus 34 plus 13.5. Which is what, 68, 78, 81.5? So 81.5% of the data is between those two values. Greater than 860, so here's 860 up here. Greater than 860, so 2.35% here, 2.5% above 740. So actually subtract those two. So this would be 2.5 minus 2.35, which is 0.15. So 0.15% of the data. And then next we are asking less than 620. So here's our 620. So let's see, 34% in here, and then the left half is 50%. You do 34 plus 13.5 plus 2.5, that makes 50, right? 50% below the mean, 50% above. So 50 plus 34 would be one way to do it. So 50 plus 34, which is 84%. and then more than one standard deviation from the mean. So exactly one standard deviation from the mean is here, one above, and then here is one below. So more than one standard deviation would be to the right of 620 or to the left of 380. So that's going to be the 13.5 plus the 2.5 is everything above 740, and then multiply by 2. So 13.5 plus 2.5, and that'll be this area here, which corresponds to the proportion more than one standard deviation above. And then you've got the corresponding area that's symmetric on the other side. So that's why we multiply by 2. So that is 16 times 2, 32. So 32% of the data. So 32% of the students, 84.15 and 81.5. So these are approximations here. We're actually going to learn a better way to do that using the functions on the calculator in the next section. But all the empirical rule problems are the same. You sketch your bell-shaped curve and you mark off your mean plus 1, 2, 3 standard deviations above, 1, 2, 3 below, and then add up the percentages inside the cutoffs that they asked for.